Hello everyone, very good afternoon. Welcome back to Pantech e-learning platform. I hope my voice is audible to everyone, right? Firstly, I would like to welcome all the participants to the session. Myself, R. Divyanjali from Pantech e-learning platform. Pantech is a place where a student can experience, innovate and implement different research and development works over this platform. This is purely a digital learning simplified platform. And today's webinar or today's session is under the caption, a webinar on blockchain. What is this blockchain? You might be hearing about this word at least till now, right? Blockchain, blockchain, blockchain. What is this? So we already know there are number of technologies which are coming up day to day, right? So blockchain is one of the most trending technology in the present criteria. Now, without any delay, we will start the session. First of all, let us know something about this blockchain. The word itself is describing blockchain. So, different blocks are interlinked with a chain to make our data to be so secure. Right? A blockchain is like a growing list of records called blocks, which are linked using some cryptography, some unlocking of key. Each block contains a cryptographic hash of the previous block. So it will be interlinked with each other previous blocks. And with a timestamp and with a transaction data. Whatever the data we are going to secure, that data. Blockchain has been having a lot of buzz these days. Why? Because it is the backbone of very famous cryptocurrency in the world. That is the Bitcoin, right? Fine. This technology is being used in many criteria like healthcare applications, medicines, insurance, smart properties, automobiles and even in government sectors also. We already know that the most successful implementation of this blockchain is Bitcoin, which is used for peer-to-peer electronic cash system, which incidentally the first implementation of blockchain technology. Now let us understand where this blockchain has come from. What is the first stage or what is the first version of this blockchain is? Bitcoin was the first which was introduced in the world by Satoshi Nakamoto. So the first person who put forwarded this Bitcoin was Satoshi Nakamoto. Fine, let us move on to the next slide. Here comes the properties of distributed ledger system. What are the different properties of distributed ledger system? What is this distributed ledger system basically representing? So distributed ledger system is nothing but it is like a database that is shared and it is basically used for sharing for multiple purpose. It It's like a centralized ledger which is used to share the information. Here comes the different properties: distributed, immutable, time-stamped, anonymous, secure, programmable. Yes, we already have discussed something about the blockchain, right? Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack or cheat the system. It's like a distributed, centralized digital ledger of transactions that is duplicated and distributed across the entire network of the computer systems within this blockchain. This technology is being adapted into many verticals like healthcare, medicines, insurance, smart properties, automobiles, and even in government sectors. History of blockchain. Bitcoin was first introduced in the world by Satoshi Nakamoto through a research-style white paper entitled A Peer-to-Peer Electronic Cash System in the year 2008. Bitcoin not only solved the double spending problem but also offered many more advantages. One such advantage worth mentioning here is the anonymity in the transactions. Satoshi, who created the system and did the first transaction, few coins on the system is totally anonymous to the entire world. What is this double spending? Yes, if you consider some problem statement like, if we are sharing some amount, okay, so we can see in the clearly here in the image, Bob is sending amount to Lisa, right? So Bob is sharing amount to Lisa in an exchange of a book. So once Lisa receives the physical amount bill, there is no way for Bob to reuse this amount for the next transaction, right? Because the physical currency is with Lisa, then he cannot reuse this. But here now if we consider some condition where the money is paid in digital format, okay, so here you can see we are sharing the amount in a digital format without any physical presence. So in this format for money exchange in digital format, so it's like after Bob gives the information or file to Lisa, he can also give a copy of file to Alice also, okay. The same digital information or file he can give to multiple people also. Both now will be interlinked, okay. They have received the amount without having any means of authenticating the digital coin. So this is called reusing the amount, which is nothing but double spending, where the sender spends same money at more than one place for obtaining services or goods for multiple vendors. So to solve this problem only, we have come up with this double spending problem. We have introduced something like centralized authority. One authority will be there which will be monitoring whether the transactions has been done or not, or whether the usage is being done for multiple cases or not, like that. So here Bob has sent his digital money to the bank, who would make an entry into its ledger debiting Bob's account. After ensuring that Bob has sufficient balance to pay for the digital money which he wants to send, that would send the money to Lisa, crediting her account into its ledger. Now it is like, when Bob cannot double spend the money, if every digital transaction is routed to a centralized authority like this, the problem of double spending will be solved, right? Next comes hashing. Hashing means it's something like key value, okay? It is one of the important function in PKI is the hashing function. A hash function maps the data of an arbitrary size to data of fixed size. Bitcoin uses SHA-256 hash function that produces a hash of output of 256 bits. So when Bob is placing an order with Lisa, it creates a message similar to the one shown above, like this. So a message is being created here, right? From Bob to Lisa, the message is like, I am sending this amount of towards the price of your ebook, and a hash function which is something like key or something like some security key, okay, that will be created and it will be shared. Before sharing, first it will be sent some message. If the message is modified, the hash value will change. So no other can resolve or no other can access the information. After having seen the importance of hashing, let us now understand the concept of Bitcoin, that is mining. Here comes the next slide where we are going to discuss about key cryptography. Key cryptography, in simple words, we can tell like asymmetric cryptography, which is used for two pairs of key like public and private. So a key is like something like a binary number which is having number of digits. Public key is used by everyone, but the private key will be used something like private organizations, particular organizations, like that. This key consists of two functions. The first one is authentication and the message privacy. When the two parties exchange the messages, it is important to establish a trust between the sender and the receiver. Especially the receiver must trust the source of message. So here you can see, when the people are exchanging the amount, first they need to share the message, right? With some key they are sharing the amount from one person to another, and they have to have some trust to believe that they are going to pay the amount. Next concept is mining. So mining here, it's nothing but when, for suppose Bob wants to send or purchase request to Lisa, he does not only send it for Lisa, it will be sent to all the chains whoever he is interlinked with, okay. He does not send to one person, rather the request message will be like overall the network, it will be shared. The message will be sent to all the connected people. So the message from Bob, it will be shared to all the people with a hashing function. Only the hash key, whoever it is having, they only can access the information or any message also. After the blocks of these messages which are formed, the miner creates a hash on the block using this hashing function. So that the third party people cannot modify the information. So if you can see here, this is the first block, this is the second block, and this is the third block of information I do have, okay. When I share the information with a message, with some transactional content and with a hash key, that hash key should be given to the next block in order to continue the chain of information. So each block in the chain consists multiple messages. A block in the chain may come from any miner. It may be coming from any person. While creating the chain of blocks, we observe the rule that hash of previous block is added to the current block or not. Here a miner, while creating the block, picks up the hash of the last block in the chain, and it will be combined with its own set of messages and creates a hash for its newly created block. This newly created block now combines with the new end for the chain, so that the chain keeps on growing as more and more blocks are being added to the miners. The next concept is proof of work. So nonce is a number such that the block's hash meets a certain criteria. It could be rather generated by hash which must have its leading 4 digits to the 0. So it is generated that hash. Here you can see the key is generated. The miner starts with a nonce value of 0 and keeps on incrementing it until it generated. So what we are doing here, we do have number of blocks and we have shared some message with the transaction details, and this hash is being added to the Okay, so what we are doing here, we are just adding this hash to the next block so that the chain is getting continued. Next comes network and mining. So here anybody who wants to obtain services from the third party who has advertised on the network, that first it will be creating a transaction with a message. Okay, so over a given of time, over some time, there could be many senders and receivers creating such transactions. All the transactions are broadcasted onto the network, to all the nodes. Like, it is not necessary for all the transactions must reach each and every other node. Okay, it will be shared to entire network. Each node assembles the new transactions to the block. Here are the set of transactions in each block which is independent of set which are created by others. This does not matter, like every transaction broadcast on the network gets included in some block over a reasonable amount of time. The miner may opt for the given priority for inclusion in the block to those with higher incentives. The node now works on finding the proof of work for its assembled block. So it will be continuing the chain as the nodes are being sharing the information. Incentives to miner. So the number of transactions in the block is determined by the predefined block. We do have hash function with that, right? And the average length of each block. And an important thing which we have to remember is the sender should not include too much information in its message. It should be simple and short. Okay. A sender generally will also add a transaction fees in terms of certain number of bitcoins. So it can be used for incentive the miner for early inclusion in his block. The other consequence in building the blockchain is mere size. Over a period of time, the entire blockchain may become too large for a node to store in its disk. So this is solved by using this Merkle tree, which we can illustrate in the next slide. So this issue of disk space which is in a node, which can be solved with this Merkle tree. Okay, here you can see the block header and previous hash function and nonce key, root hash, that will be divided for different hash keys. Okay, where the transactions are given, transaction 1, 2, 3, 4, like that. The block header now contains the hash of previous block and a nonce and the root hash for all the transactions in the current block in a Merkle tree. So the root hash includes the hashes of all the transactions within the block. These transactions will be illustrated like it will be deleting or it will be using for negative purpose like that. So now you can see the blockchain here, how it will be shared the information. By sharing the information in this format, previously adding to the present block in this format, we can save the disk space. This strategy is used by a normal client who is interested in just receiving the payments from others. Okay, the miners need not to save the full blockchain. It will be like only it will be received, that's it. Next comes payment verification. For suppose if we consider a problem statement like a vendor you may like to verify for a certain payment made in the past, the blockchain you are holding on your machine contains only the block headers. Then the transaction which you are searching for is missing in the copy of your blockchain. Here we will see an example for this. We assume like you are looking for transaction 103. Here is 102, 103, 103. Yes, transaction 103. Okay. We are unable to see this contents of transaction 3 because it is already secured. So after checking the security, then only we can proceed further. We can trust and we can proceed for the transaction. Here comes the next slide, resolving conflicts. So here you can see block 1, 2, 3. After the third block, we are dividing the information or sharing the information to two blocks, 104A and B. So for which block it has to share the information first. All the transactions in this block will be returned to the transaction pool, okay, and it will be added to the future block. Then the conflicts arises for which block it has to share the information firstly and prioritarily. So here you can see the priority has been given to the first one, next followed by the next. Moving on to the next slide, here comes the privacy. Okay, so as the ledger which is recording all the Bitcoin transactions is made truly public, the privacy is at the stake. Anybody in the world would be able to know who paid to whom. The traditional banking system is able to maintain this kind of privacy by keeping its records confidential. Privacy in Bitcoin system is achieved by different strategy. So we can tell that a sender of Bitcoin needs to know to whom they are paying amount, okay. So he asks for the public key of the vendor to which he desires to make the payment. This public key can be anonymous. In the sense, as a vendor of some services, when somebody asks you where to send the payment, you would simply send him your public key. The association of this public key with you is not recorded anywhere in the ledger. So anybody outside of the transaction would only know how much money is transacted and to which public key the money is paid out. So to achieve this higher degree of privacy for every transaction, you may generate a new private or public key for each transaction so that multiple transactions may be used or it cannot be grouped together for a third party person. For an outsider, this would simply like the transaction is done, that's it. Okay, so any online internet based systems is vulnerable to abuses. Moving on to the next slide, here comes the mitigating attacks. We do have 3 types of mitigating attacks in Bitcoin. The first one is race attack. The second one is Finney attack. And the third one is 51% attack. Let us know in detail about these. So race attack is nothing but we will be sharing some coins to different vendors, right? If the vendors do not wait for the block confirmation before delivering the goods, they will very soon realize that the transaction was rejected. During this mining process only it will be rejected. So to find some solution for this, the vendor must wait at least 1 block confirmation before sending out the goods. That is about race attack. Moving on to this Finney attack, the miner mines a block with its transaction, okay, and it does not release in the system directly. The same coins in the second transaction and it will be released like pre-mined block. The second transaction would be rejected eventually by another miners, but this will take some time to complete its process. So to solve this issue, the seller should wait at least 6 blocks confirmation before the releasing of goods. The next attack is 51% attack. So in this, what we will be doing is, we will be assuming that somebody owns 51% of computing the power of network. The attacker in this kind of attack mines a private blockchain where he double spends the coins. He owns the majority of computing power. He is guaranteed that his privacy key or blockchain at any point will be no longer than the honest network. So he then realizes that his private blockchain in the system making all the transactions of earlier recorded, which are valid or not. So this kind of vicious attack, which is very expensive to acquire the computing power, which is equal or exceeds 51% of the computing power of the entire network. Next comes what are the languages required to use or to develop blockchain projects. Okay, we can prefer any of the languages over here: Java, Python, Solidity, Node, Scalability. All these languages we can use. Now that we will move on to the application oriented part, I have a very small example over here to explain you, where I'll explain you about the Python coding. Okay.
Yeah. Previous one.
Okay. First I have opened this, where I am going to consider different library files. First I have imported these modules, JSON and hash library. Now from datetime we have imported datetime module. Here I will initialize the block first of all, and in this I will give the timestamp, data and previous hash and calculate that hash and store in this variable. Next I am defining calculate this hash by self values. Just run the code. Now here from block library file we have imported this module. Next from datetime we have imported datetime module. I am defining the class as blockchain, where I am initializing the information with super keyword. Number of blocks, how many blocks you want, that we have to give here. We have initialized block 0, right? Now I am defining here previous hash should be added to that, whether it is valid or not, that we have to check here. Now if the current block plus 1 is not equal to the block index value, then it will write as false. Elif it will check another condition over here, and if this condition also false, it will again write it as false. Elif the third condition, it will return false and true. Now defining to add a block over here, timestamp, index value and previous hash should be considered, which will create altogetherly a new block. Again it will check the condition if else. If this condition is false, then it will just give me the print statement like the block is invalid. Now defining the print blockchain, for block in self chain, if it is present, then it will print in this format. First it will print the block, next index value with real time information, next it will print the data, next it will print the hash. Now go to run, click on run module. Here comes the main code. Okay, from blockchain we have imported this module. Next I am defining the function as main function. What I have taken the blockchain and stored in this variable. Now I will give some value over here, enter the number of blocks to be created. How many number of blocks you want, that it should be given here. Now for x variable within the range n, whatever the range you have given, it will check, enter the data for block. What is the data to be stored in that block, and add that information to the block. Next it will print that blockchain. If it is the main function, that will be printed. Now run this. Enter the number of blocks to be created. I'll give two blocks to be created. Enter data for block 1. I'll give something like add. Enter data for block 2. Difference. Fine. Now you can see here the blocks are created with index value, with timestamp and date time. Next block name Genesis block. This is my key. Okay, block 1, block 2. And this is also timestamp. Next block 1 name add, block 2 name difference. And this is the key, hash key. Okay, this is how the blocks are being created. I hope everyone enjoyed the session. And if you find any difficulty at any point of the explanation, please let me know that in the comment section. I'll just wait for 2 more minutes. Let me check any students are having any doubts or not. I hope you have gained the basic knowledge on blockchain technology, at least to the very basic level. Find no queries over the comments. You will receive the attendance link within no time in the description. Don't worry about attendance. And if you like the session, please do like, comment and subscribe to Pantech e-learning platform. Thank you all. Have a very nice time.